In this video, we'll generate the DeMoivre sign using the functions IMPOWER, imaginary, complex, factorial, cosine, and sine, and the Taylor series sum. We begin with the Taylor series using the function itself. So the value of f will be data validation, list of items, and this will be from 0.4 up to 1.6. So we can start with 0.4. And the function itself, it is the summation of a times x to the power n, where the value of n is from 0 to infinity. And the value of a is equal to array formula. That is sine n pi f. So sine n times pi times f. That's the first part, the numerator. Now the denominator, factorial of n. And now we can complete the first Taylor series function. So array formula, series sum of the x values raised to the power n, where n starts from 0 incremented by 1. And the coefficient will be this range. And we'll do the same thing for the second, which is the DeMoivre's Taylor series, which is the summation of b times x to the power n, and n is from 0 to infinity. 20 is good enough. And the value of b is equal to array formula. That is this is the IMPOWER, meaning this complex number raised to the power n. So we begin with the complex number. Complex. The first part is cosine pi f. Cosine pi f times f. The second part is plus I sine pi f. So comma, that is sine pi f. So sine pi times f, and close parenthesis, and enter. And this is raised to the power n. So we use the function IMPOWER. IMPOWER. That's IMPOWER. Raised to the power n. So this will be IMPOWER, comma, and n. So raised to the power n. So IMPOWER, the complex number, to the power n. So this is the complex power raised to the power n. And finally, we take the imaginary part of the whole thing. So we use the imaginary function. Imaginary. And now that we have entered the imaginary, we now use the denominator, is the factorial. So factorial of n. And enter. These values are exactly the same. Now we continue with the Taylor series expansion of the DeMoivre's sign. So array formula, series sum of the x values raised to the power n, where n starts from 0, incremented by 1. And the coefficient will be this range, that's our b. That's summation of b times x to the power n. So we are using b coefficients. And we'll chart this. So insert chart. And we use scatter chart. Column is label. And the trend line, that is, the type will be polynomial. The degree will be 6. for the label used equation, so we don't need the title. And here's our trend line and polynomial of the DeMoivre sine and its function. So begin with the function itself. Change this to 0.5. Now it's a steady state sine function. We also change the DeMoivre sine function to 0.5. Now they're the same. It's a steady state sine function. Change the value of f to 0.6. Now it's a decaying sine function. We also change the DeMoivre to 0.6. Now it's a decaying sine function. Change the value of f to 1.4. Also a decaying sine function, but it's negative. We also change this to 0.4. It's also a decaying sine function, but it's negative. Change this to 1.5. Now this is a negative sine. Change this to 1.5. So a steady state negative sine function. Change this to 1.6. Now it's an expanding negative sine. Change this also to 1.6. Now they are both the same, expanding negative sine. So this completes the use of the functions IMPOWER, imaginary, complex, factorial, cosine, and sine to generate the DeMoivre sine formula, and it's the Taylor series of both.